welcome to the Chemistry 121 Supplemental Instruction video series. I'm Smokey, and in today's episode we're going to be talking a little bit about transitional nomenclature.
Transitional nomenclature, you say?
Yes.
It's like nomenclature that's transitional, I take it?
It is.
By the way, my name is Kevin Martin.
And we'll be presenting this episode for you guys today.
Okay, so why do we need this transitional nomenclature? It sounds magical.
It is. It's very mystical.
Okay.
Okay, so Kevin, you remember on the periodic table, there's all those elements in the middle in the D block, and they're called the transitional elements.
Oh yeah, it's that big block of metals that are weird and stuff.
Exactly. It's basically a whole bunch of metals that don't know what their charge is. They're undecided about it.
Okay.
But unfortunately, compounds are made with them, and as such, we gotta name them.
Dang.
Which can be difficult.
Yeah.
So it's important to be able to, know some of the different techniques and how to name transitional elements. So therefore, transitional nomenclature.
Okay, so it is important.
Yes.
Alright.
Okay. Why don't you pick a transitional element?
Let's do iron.
Iron. Very good. Iron is Fe.
Alright.
Okay.
Makes complete sense.
I know, right? Well, it's actually from, I think it's the Latin root ferrous or something like that.
Okay.
Which I believe is for metal or iron or something. I'm not sure. That ancient language that, our own language is based on. So.
Yeah, alright. So,
okay.
Iron.
Iron. Now, the thing is, iron has no idea what its charge wants to be.
Man, it needs to be more decisive.
It does. So, what happens a lot of the times is that it's up to an anion, or a negatively charged ion, to come in and bond with the transitional element, and it will decide what charge the transitional element gets.
So it's like the guy that comes in and says, "Make up your mind!"
Pretty much, exactly.
Okay.
To put things lightly, I guess.
Fair enough.
Okay, so pick a non-metal.
Phosphorus.
Phosphorus, okay. We can tack a phosphorus onto there, make things simple. Okay.
Okay.
So there we go. We have iron and phosphorus. Now, here's the thing. We're not sure what the charge on iron is yet.
Okay.
But we do know the charge on phosphorus. Since it's a nonmetal, it's an anion, its charge is always fixed. So basically what you do when you see the chemical formulas for transitional elements, basically you find the nonmetal, get the charge, and work backwards.
Okay.
Okay? So we know that phosphorus has a -3 charge.
Alright.
Right here. And like so. Okay? Now we know that since the iron and the phosphorus are bonded, overall it's got to be neutral.
Yeah.
So because phosphorus is a -3 charge, you know that in order for it to be neutral, what charge does iron have to have?
Well, if there was only one iron and only one phosphorus, then I guess the iron would also have to be +3.
Exactly. Just like that, which balances it out and you get FeP.
Okay.
Okay?
Now you said iron has, multiple charges. What if we pair it with something like sulfur?
Okay, so that would change it. So let's go ahead and actually, I'm going to go ahead and write the name of this first. That way we can kind of touch on that right quick, and then we'll get to the one with sulfur. So whenever you name these things, basically going from the chemical formula to the actual name, you're going to use Roman numerals to designate the charge on the metal.
Okay.
Okay, so we're basically going to name it iron, since it is iron, obviously. And then we're going to do parentheses.
Okay.
And the Roman numeral 3 to indicate it has a +3 charge.
Okay.
And then, of course, phosphide.
So it's a lot like naming ionic compounds. You just need that Roman numeral in parentheses.
Basically, that's exactly it.
Okay. Well, it's not too bad.
Makes sense?
Yeah, it makes sense.
Okay, so let's go ahead and you want to pair this thing up with sulfur, right?
Yeah, let's see what happens when we do that.
Okay. Let's go ahead. I'm going to get blue so that way we can kind of designate between these. And we'll start over. Okay. So iron again, paired with sulfur.
Okay.
So we have FeS.
Alright, let me try this.
Okay.
For a minute. Okay, so sulfur, where it is in the periodic table, it has a -2 charge. And then, as it is, the whole compound has to be neutral. So to cancel a -2, we need a +2 from the iron. And so since there's only one iron, it's going to be +2.
Exactly.
Okay, so if I try to name it, iron again.
Yep.
Then parentheses. So if it has a charge of +2, then I guess we need a Roman numeral 2.
Yep.
And then sulfide.
Just like so.
That's pretty easy, actually.
It is pretty easy.
Alright.
And that's basically how you do transitional nomenclature.
Oh, really?
Mm-hmm.
That's all there is to it?
That's all there is to it.
Wow.
So I think we'll probably do another episode to give some a little bit more complicated examples because, obviously, nomenclature can get a lot trickier, but...
Yeah, of course. It always does.
For now, we should probably let these guys, think about this for a little bit, let it sink in, and
Alright, fair
that
enough.
sort of stuff. Because,
Okay.
Roman numerals, they are kind of weird.
Yeah.
So, just remember, the transitional elements have no idea what they want to do.
It's up to the anions to make up their minds.
Exactly.
Okay.
You know what you want to do today?
I have no idea.
I don't know either. I guess I can understand the transitional elements.
Yeah, we should probably find some anions or something to make up our minds.
I think so. Let's go do that.
Yeah.
Bye.
Right.